Okay, so we want to determine the measure of the arc DE. So DE goes from D to E. Remember, this is a minor arc because it's only 2 letters. So from D to E is this piece right here that's purple. So I want to measure that. Now remember, if you follow this angle in, is a central angle because, well, first off, it cheats and it tells you right there. But secondly, you see that the center is the vertex. So remember, what's true is that angle measure is equal to the measure of the arc. So that means if I have an 81 on the inside, then that means it's 81 on the outside. And that is actually all we have to do for this one. So you should have written the measure of arc DE equals 81 degrees. Okay, if you did A level, so we want to determine the measure of the arc from D to B. So that's this chunk right here. Now once again, this angle right here is also a central angle because the vertex is in the center. So that means the measure of the arc is going to be equal to the measure of the angle. So if we knew the angles inside here, we could add them together to get the whole arc. Now there's a couple ways to do this. Now we know some things are true. We do know things about vertical angles. We know things about whole circles are 360. We know things that half circles are 180. So we can use all of this information. So I have this 81 up here. Now remember, I could take this half a circle. So this whole side has to add it to be 180 degrees because that is a half of a circle. So this part of it from here to here is 81. So if I wanted to get the rest of it, I do know that if I want this chunk out here, this purple arc, which is D to B, I can just do 180 minus 81. What is 180 minus 81? My calculator is not even on. Minus 81 is 99 degrees. So that means this whole chunk is 99 degrees. So that means the arc outside is also 99 degrees. Because this 81 would be 81 here. And so obviously the whole half is going to be that. Okay, next row here. So next we have some angles. These are inscribed angles. Now remember, inscribed means that the vertex, see the blue angle here, bluish greenish, the vertex is on the circle. It's on the circle. So that means that it is not going to be equal like up here. Remember that the arc, this is like your little ice cream cone, your arc is going to be 2 times as big. So 2 times the size of the angle. So if I know this is 42, we know this is the big part. We have to come in here to the Y, and we know that it's going to be the smaller part. Obviously, you can see the little cone is smaller part, so it's going to be 42 cut in half. So in order to get this angle, we're going to have to do 42 divided by 2. So got our calculator, 42 divided by 2. And we get 21. So that means this angle here is 21 degrees. So it says angle BAC is inscribed in the circle BAC. What is the angle measure for Y? So that would be 21 degrees. It also says angle ACD is inscribed in the circle as shown. So let me get a new color. So we want to go from A to C to D. That is also inscribed because look at the vertex is on the circle. Right here is the vertex. That C is on the circle. So this is a square here, so that tells us it's around 90 degrees. So this is a 90-degree angle right there. So that means it's intercepted arc, which is from here. See how it crosses there and there? So we got to go from there to there. So that is pretty far. So we know that it's inscribed, so that means that the angle is half as big as the arc. Remember, the arc is always big. They're big fat ice cream cone. This is the skinny part of the bottom of the cone. So if this is 90, then that means we have to do 90 times 2 to get to the outside. So 90 times 2, it's going to be 180. So this is 180 degrees coming around the outside here, which obviously this picture is not necessarily drawn to scale, but it does look like it's about a half of a circle. Actually, it might be just maybe I just drew over it. So it says, what is the measure for X? You would say X is 180 because it has the degrees on it. Okay, this one over here. We're going to use the picture below to find the measure of arc B to D. So B to D, that is this red one right here. All right, so we do have some inscribed angles. So this angle right here, this red one, is the one that wraps around this little ice cream cone. So we know that the cone part is the smaller part, so we got to go out here. So we do know the vertex is on the circle, so it's inscribed. So if this is 23, then that means this out here is going to be 2 times 23. It's going to be twice as big. So 2 times 23 is 46 degrees. So from B to D is 46 degrees. It says find each angle measure in the large inscribed triangle. Okay. Do they mean angle? All right. Okay, let's just find the rest of the angles on here. Okay, so we have this 130 from here to here, right? So that's this arc. We can see that we have another inscribed angle that wraps around that. So see this green guy right here? So here's another ice cream cone. So this is the ice cream is the big part. And so that means in order to come all the way in here to this angle over here, we need to take this 130 and divide it by 2. So 130 divided by 2 is 65. So that means this is 65 degrees in here. Okay. We can probably get some more angle measures. That's probably what they want us to do. They said inscribed triangle, but this triangle is not officially inscribed because if it was inscribed, and that means all 3 of the vertices would be touching the circle, and they're not. But we have this 65 and we have this 23, so we can get this angle right here because that's a triangle. So let's see. Let's do 23 plus 65. So 23 plus 65, we are up to 88. And so we need to subtract that from 180. So 180 minus 88 should give us 92. And so that means this angle here is 92 degrees. And you could check that because inside this triangle should add to 180. So let's see, 23 plus 92 plus 65 should give us 180. If it does, then we're all good. I'm going to assume we're good. Now we could get some more angles here. We could say that this is 92, so this over here is 92 because that's vertical angles across from each other. We could get, let's, I don't know what other color to use here. I'll use this orange highlighter. This right here is a vertex on the angle, this orange one. So this and this also wrap around this green piece. So that's 130. So that means this little corner of this triangle right here, that corner is also half of that, which is 65 degrees. And that would also make this piece 23 in that little crack. So these are actually two, looks like similar triangles because they have 3 congruent angles inside of that circle. Okay, next part we have inscribed quadrilaterals. Okay, so inscribed quadrilateral means that all 4, 1, 2, 3, 4, all 4 of the vertices are on the circle, which is true. And if that is true, then we know that the opposite angles add up to 180, because remember, they're going to be supplementary. So that means this 71 and this y have to add up to be 180. So that's basically 71 plus y has to equal 180 degrees. So you can just solve that by minus 171 on both sides. We're going to get y is equal to, what we got here, 180 minus 71, and that's 109. So y is 109, and also same is going to be true for x plus 80 has to equal 180, and you could probably do that in your head. That's x is 100. Okay, last one. It's kind of small, but the same idea. This is inscribed because we got 1, 2, 3, 4. All vertices are on the circle. So that means when you add these two up together, they should add to equal 180, and the same goes for those two. Okay, so let's go ahead and do this first diagonal I drew. So that's a 5x plus, the other side is a 3x plus 8. That has to add up to be 180. So do your little algebra. We got some like terms. We got 8x plus 8 equals 180, minus 8 on both sides. We got 8x equals 172. Okay, we got 172. We got to divide that by 8. And we get 21.5. So divide by 8, and we get x is equal to 21.5. And, oh, look at that. It said solve for y, and I just solved for x. Oh, well. Good practice for the algebra. So if I do the other diagonal, we've got a 4y minus a 12, plus a 102 has to equal 180. So we have some like terms here. We've got a negative 12 plus a 102. They're like, so we're going to add them together. That's a 90 when you put that together. So we've got 4y plus a 90 equals 180, minus 90 on both sides. We got 4y equals 90. Divide by 4, and we've got 90 divided by 4. We've got 22.5. So y is equal to 22.5. So we've got the x and the y, even though we only need the y. See how extra we are.